Welcome to the session 4 of Unit 3, the session 4 total probability. By the end of this session, we should be able to identify and partition of a sample space of an experiment. I use a partition of a sample space to describe total probability, and I use total probability theorem to compute probabilities involving the use of total probability theorem in a real life situation. Now let's get going. Partitioning of a set. Now, a partition of a set will be said as the combination of non-empty, non-overlapping subset of a sample space whose union is the sample space itself. So the partitioning will be a non-empty and non-overlapping subset of the sample space, and the union of the partitioning will be the same as the sample space. So assuming that we have a sample space this way as S, so I can partition this one like this, partition this one like this, and also partition like this. So let's say here is partition 1, partition 2, partition 3, and partition 4. Now this is what we're saying, that each of these partition of the sample space is not empty and they are not overlapping. I mean, they do not intersect. And when you find the union of all the union of all the partitioning, it should give us the sample space. So assuming that the first one is A1, and the partition are in A, and the second will be A2, A3, and A4. Yes, that's what we mean by partitioning of a sample space into a subset. So you could see from here that set X equal to A1 union A2 union what? A3. So when you add up all the union of the partitioning, it should be equal to the sample space. So if B is any event with this S, then we can express B as a union of a subset. So from there, then you could say that B should be equal to B intersection A1 union B intersection A2 up to the union of B intersection A n, that's the end partitioning, and the events are mutually exclusive. And so when we apply probability to this, as we said earlier, then the whole thing will now be probability of B equaling probability of all this. That's A intersection B, probability of B intersection A1 plus probability of B intersection A2 plus up to probability of B intersection what? AN. But then from the conditional probability, we know that probability of B intersection A will give us probability of B given A times probability of A with the multiplication law in mind. So if the A are the various partitions, then we might have AI as I start from 1 to N, while N will give us the first, or the one will give, AI will give us all the various partitioning we have up to the nth term. And this could also be written as probability of B given AI times probability of AI. So this will be the same as probability of B given A1 times probability of A1 plus probability of B given A2 times probability of A2 up to probability of B given AN times probability of AN. So when it goes on like this, then we could sum everything up to probability of B equal to the summation of I equal to 1 up to N of probability of B given AI times probability of AI. Well, this is what we call the theorem of total probability. Now, how do we use it? Maybe an example will work out for us. An example 1. A mathematics teacher gives only 2 types of examination, easy and hard. You will get a hard examination with a probability of 0.8. The probability that the first question on the examination will be marked as difficult is 0.9 if the examination is hard, and 0.15 otherwise. What is the probability that the first question on the examination is marked difficult? And what's the probability that your exam is hard, given that the first question on the exam is marked difficult? Quite an interesting question, right? But it's easy to approach. Now let's set preambles down with a solution. Now remember the question that we will get a hard examination probability of 0.8, and the probability that the first question on the examination is marked difficult is 0.9 if the exam is hard, otherwise 0.15, that's if the exam is not hard. And you have to find a probability that the first question on the exam is marked difficult. So we let the A be the event that the first question on the exam is marked difficult. I'm going to let B be the event that, or B1 be the event that the exam is hard. Then automatically B2 will be the event that the exam is easy. And we have to find the probability that the first question on the examination is marked difficult. That's the probability of A. And the probability of A will be equal to the summation from I equal to 1 up to 2, given a probability of A given BI times probability of BI. You know, we have B1 and B2. So AI will now give us probability of A giving BI, will now give probability of A giving B1 times probability of B1 plus probability of A giving B2 times probability of what? B2. You get it now, right? Good. Now, probability of probability of A giving B1. Remember, B1 is the event that the exam is hard. That is 0.9. And if it is hard, it is marked what? Difficult. That's 0.8. That is 0.8. Or it is hard, given that it is marked difficult. So that's 0.9 at probability of A, that the first question is marked difficult, given that it is what? Hard. Multiplying the probability of B1, that is 0.8, that the examination is what? Is hard. Then plus, now we're going to have plus probability of A giving B2 times probability of A. And B2 signify that the exam is easy. And you know, if the exam is easy, it will be 0.15. That's otherwise, as the question said. And then if the question is hard, we are giving what? 0. Or the question is difficult, we are giving 0.9. If it is easy, then it will be 0.1. So if it is easy, the probability that it is marked hard or it's marked hard will be 0.15. So that's what we have here. 0.15 times 0.1. Then we add the two probabilities together. That will give us the result of 0.735. Did you get it? Yes, because from the preamble, we're told that the probability that the first question on the examination will be marked as difficult is 0.9 if the exam is hard, and 0.5 otherwise, 0.15 otherwise. So otherwise means that it is not hard. Then that will be 0.15. And if the exam is not hard, then that will be 0.1 times 0.15, which is the first question, is marked difficult. You get it now. That's why you have 0.15 times 0.1. Because the 0.9 and the 0.1 are mutually exclusive. If it's not hard, then it's easy. You get it. So the B part of the question, say we should find what? What did the B part ask us to find? That find B1 giving A. B1 giving A. And what are the B1 says? So you know that our B1 is the event that the exam is hard. So we have to find the probability that the exam is hard, given that it is marked difficult. That's B1 giving A. And by the conditional probability and the total probability manipulation, we have probability of B1 giving A be equal to probability of A giving B1 times probability of B1 all over probability of A. And the probability of A giving B1 times probability of B1 is what we had earlier from the A part, that is 0.9 times 0.8 all over probability of A. And what is probability of A? Probability of A is the result that we had in the A part of the question, that's 0.735. And when we work at the calculation well, should be getting something like 0.979. That is total probability for you.